Hello students, let's continue our discussion in system modeling and simulation. Okay, SMS. So next is the Weibull distribution. So we are talking about the inverse transformation technique. Yesterday, or I mean in the previous session, we have discussed about some of the type of the distributions, like as you can see over here. Let us quickly recall it: uniform distribution as well as the exponential distribution, right? Under inverse transformation technique. It is in the previous session. So next type is Weibull distribution. As per the thesis, the probability density function for the Weibull distribution, they are the f of x. As you can see, f of x equal to, its value is, as per the thesis, so beta divided by alpha to the ratio beta into x to the power beta minus 1 in multiplication with e to the power minus x divided by alpha to the whole power beta. As you can see the expression here, please go through the expression. That is for value x is greater than or equal to 0. Okay, in a case if the value of x is a negative number, that is less than 0, its value, the probability density function value remains 0. What then you might ask, what is the meaning of alpha and beta? See, they are called as scale parameter. Okay, alpha and beta, they are called as scale parameter, and its value should be greater than 0. Alpha is greater than 0, beta greater than 0, called as scale and shape parameters for the distribution. Okay, let us see what exactly the meaning and all later. So to generate the Weibull variate, then, that is cumulative distributive function, or cumulative distribution function, capital F of x, that is called as variate. Okay, how to generate the variate for Weibull distribution? There are 3 steps we have supposed to follow. And the first step, as you can see, f of x, capital F of x, which is given as, okay, 1 minus e to the power minus of x divided by alpha the whole beta. That is for, see, it is for what we have taken, this expression, this part we have taken. Okay, that is for x is greater than or equal to 0. Okay, fine, slightly that is modified. Then set the f of x value to the same value, which is equal to r. Okay, and separate x, that is what variate is, capital X. You have to separate capital X, which is equal to what will happen. So on left hand side we keep this capital X. Okay, we substitute over here, it will become my alpha of minus log to the power log to the base e 1 minus r to the power of 1 divided by beta. Okay, so we'll be seeing the examples and all later. Please remember these equations, because these equations are as per the thesis. So we are speaking about the random variates for the different types of distribution. We are talking about the Weibull distribution, and this is the expression we get, that is x equal to alpha into minus ln of 1 minus r to the power whole power 1 by beta. Okay, and the scale and shape parameters are alpha and beta, its value. So Weibull variate, x is called as Weibull variate, then x to the power beta is an exponential variate with the mean value alpha to the power beta. As you can see these statements, okay, the meaning of the statements which are mentioned over here. Just to go through the page number once, page number 244, that tells you about the distribution, this particular type of distribution. Next type of distribution, the random variate generation. Next type is triangular distribution. Consider a random variable x that has a probability density function PDF f of x equal to, this is for triangular distribution. Okay, small f of x, that is PDF, which is equal to x for value of x. Simple, it is a simple expression where x lies between 0 and 1, and its value is 2 minus x, where x lies between 1 and 2. Very simple, otherwise it is 0. Okay, two values, two different range we are considering. Value of x is lies between 0 and 1 and 1 and 2. So if it is 1 and 2, between 1 and 2, then 2 minus x is the probability density function value. Normal case it is x, that is between 0 and 1, and otherwise if it is a negative value less than 0, we mark it as f of x is 0 itself. Then we have to generate the random variate for this by considering the cumulative distribution function, CDF, that is capital F of x, so which is equal to, just go through these expressions. Yeah, just go through these expressions, I have already highlighted. So capital F of x, which is equal to, so that is equal to 0 for x is less than or equal to 0. Otherwise, see, if it lies between 0 and 1, then x square by 2 as per the triangular distribution function. Then if it lies between one more range, you have to consider 1 and 2, and greater than 2 is also given. Okay, 1 and 2 means 1 minus 2 by x the whole square by 2. Otherwise 1, that is x greater than 2. Please remember, try to remember these ranges and all. 4 different ranges we are considering for probability cumulative distributive function, that is less than 0, as you are aware of. For all the types of random variates, for less than 0 its value will be 0 only. Then for remaining cases, that is lies between, if it lies between 0 and 1, then x square by 2 is the value. 1 and 2 means 1 minus 2 by 2 minus x the whole square by 2. Otherwise 1, that is for greater than x value greater than 2. Okay, that is what CDF value is. Fine. You can see the diagrammatic representation of the probability density function PDF, that is small f of x for the triangular distribution. Okay, see three different ranges, I mean range of values we are considering. What are those? As you can see here, 0, 1 as well as 2. Okay, 0, 1 as well as 2. Here f of x value is given as 1 this side. So just go through the expression once. So if the value of x is 1, f of x value is, we have observed, that is 1. So triangular representation of the distributive values. Now let us write how to let us discuss about how to write the random variate for triangular distribution. So for the different cases, that is value of x lies between 0 and 1 and lies between 1 and 2. Those cases we have to consider, that is capital F of x, the cumulative distributive function you are supposed to consider. Just observe these formulas for triangular distribution, capital F of x. As you can go through the values, 0 and 1 it is x square by 2, and 1 and 2 it is 1 minus 2 minus x the whole square divided by 2, as you can see here, which I am pointing, right? For greater than 2 it will become 1. Fine. Just if you remember these formulas, you can easily write the variate values. So variate values are written here. R, value of r, which is equal to capital X square divided by 2, as we have discussed already, right? Which is there over here, as you can see, x square by 2, that is for f of x, right? F of x. Now capital X, we are writing capital X, you have to replace that by capital X, that's it. X square by 2 it will be, that is for the range of value 0 and 1. Then 1 and 2, 1 minus, we have 1 minus, as you can see, 2 minus x the whole square divided by 2, right? This is the expression, two expressions we have considered, right? Right, you can compare the expressions over here. Then it will become 1 for greater than 2, 0 for less than x value less than 0, right? Go through the description once. Okay, we are calling this as with the equation numbers. This is marked as, sorry, this is marked as 8.7 and this is marked as 8.8, as you can see here. Now from the equation you have to simplify for x, that is where x is the variate. Take r on right hand side, x on left hand side. From this expression 8.7, what you will get? Try to simplify it, right? 2r, which is equal to x square, isn't it? 2r equal to x square, or x square equal to, let me use the pen, x square equal to 2r, right? Then x equal to, what is the value of x? X equal to square root of 2r, isn't it? That is what we are getting, x equal to square root of 2r, that is for r which lies between 0 and half, because square root we are considering. What is square root? to the power 1 by 2, isn't it? That's why while writing the range, please be careful, since range is not between 0 and 1, because the square root we are considering. Square root means to the ratio, that is to the power of 1 by 2, right? Then next is what? R equal to 1 minus 2 minus x the whole square divided by 2. Once again you are supposed to simplify. For x, take r on right hand side, x on left hand side. It will become, after simplification, see, this will become, as you can try, you will be getting 2r equal to 2 minus 2 minus x the whole square. That is what you are getting, isn't it? You have to take some values on left hand side and some values on right hand side, right? So the value of x will be what? 2 minus, so 2 minus 1 by r, that square root we have to take now. Again the range lies between half to 1. Please understand, half to 1, 1 by 2 to 1, because 1 by 2 we are supposed to consider because of the square root thing. Okay, that is what the variate is. This is the random variate formula for triangular distribution. Please understand, we are speaking about the triangular distribution. Okay, let's continue our discussion in the next video. Watch the videos repeatedly. Please remember, watch the videos repeatedly, note down the things, because this contains numericals, right? These expressions, you're supposed to write it on your notebook. If you have any doubt, you ask.